Hello and welcome everyone. We're so glad to have you join us virtually for this Microsoft Build session on developing end-to-end analytic solutions with the latest Azure Synapse features. I'm Matthew Hicks, and I'll be the moderator for this session. We have a dedicated area for you to ask questions, and we request you to take advantage of it to keep this session interactive. I'll bring up a bunch of questions for the presenter to address in the Q&A section towards the later part of the session. Without taking any more time, let me invite Charles Feddersen to drive us through the session. Charles, the floor is all yours.
Thanks, Matt. Hi, everyone, and thanks for joining the session. As everyone probably saw yesterday, we announced the public preview of Azure Synapse Analytics. In the session today, I'd just like to talk about some of the new features that we've announced for Synapse, and then also show you a set of demos to really bring those features to life. As folks know with Azure Synapse, this is a single, fully integrated service that provides an end-to-end analytics solution. Everything from data integration through data pipelines, and perhaps you saw yesterday the announcements we made around Synapse Link for that direct integration with Cosmos DB. We bring SQL engines and Apache Spark for Synapse into the service as well, so you can run those traditional enterprise data warehouse workloads at scale with the performance and concurrency that you require, and then also do data science workloads or complex transformations using the Spark engine. We enable all of this through the Synapse Studio, and that's going to be the primary vehicle that we use to show all of the demos today. At Build, we've launched a lot of new features, aside from just public previewing the service. I don't have time to cover all of them here, but I will talk just about a few of them just quickly. One of the critical features for running enterprise data workloads, enterprise data warehouses, I should say, at scale is workload isolation, the ability to guarantee resource reservations within a compute cluster so that multiple different teams can work over the data without getting in each other's way. Today, we're pleased to announce the GA of that feature. And so now you can create what we call workload groups within a cluster. And through a couple of simple thresholds, min and max resource reservations, these will automatically adjust depending on the workload in the cluster, but always guarantee a quality experience for users running their workloads. We've also introduced the predict scoring. This brings the Onyx runtime into the SQL engine and enables you to take machine learning models that you've built in the Onyx format, maybe in the Spark engine or Azure Machine Learning or elsewhere, and host them in Synapse so that you can actually invoke them from the SQL language and democratize those predictions into reports or dashboards or really any BI tool that supports Synapse. And I'm going to show you how that works today as well. Delta Lake is a big topic and something that a lot of customers have asked us for. Today, we're announcing that we've now got version 0.6 support for Delta Lake tables in Azure Synapse Analytics. In our pipelines, we've provided native support for the common data model. The common data model in Data Lake enables you to egress data into effectively a self-describing format. I'm going to give you a peek into how that works today for really streamlining the analytics that you're doing over your Data Lake. And then finally, one of the big announcements was around Synapse Link for Cosmos DB, the ability to effectively check a box and have all of that real-time operational data that's coming into Cosmos DB flowing directly into Synapse for Analytics, where you can join it with all of your other data from operational systems. We've got a separate session on that, which really deep dives into the tech, and I'd encourage you to look at that if you've got some time. And then finally, managed virtual networks. The managed VNet feature within Synapse is an option that you set during provisioning. And it really gets around some of the challenges that customers have traditionally had with VNets. Customers sometimes manage hundreds of VNets. Lifecycle management is hard. Subnets are hard to configure because you've got to pre-configure them to allow for the size that a cluster may potentially scale to. And in a hyper-elastic world in the cloud, that can be challenging. Synapse eliminates the burden of VNets. We handle all of this completely automatically, again, through a simple checkbox through provisioning. And it means that you don't need to worry about this, but still know that your data is secure as it moves between these capabilities within the Synapse service by only operating with endpoints. So this is just a highlight of some of the features. But like I said, let's get straight into these demos, because I think this is where we can make it real. In this session, I'm going to show you 4 demos. I've broken it apart just to show some of these features quite cleanly. In the first demo, I'm going to interop with data that's stored in my data lake, but it's been egressed there from a Dynamics 365 CRM system into the CDM format. And on the back of that, I'm going to show you how data sharing can work, just quickly supporting both the data lake and the data warehouse. The second demo is also quite simple. I'm going to show you how we've introduced schema inference over delimited files for our SQL serverless form factor. The third demo gets a little more complicated, and here I want to put the focus both on the multiple modalities for ingesting data into the platform, and then also enhancements we've made to the SQL surface area within the Synapse pools that aid you both in developer productivity, but also migrating a lot of those legacy workloads. And then finally, we're going to take a little peek into the future. We're going to look at some of the hardware acceleration that we're introducing into the Spark engine for doing delimited file parsing in Synapse. So let's get started. I'm going to flip over and start in Synapse Studio. And here you can see Synapse is my fully integrated development experience. On the left-hand side, I've got a browser where I can look at all of my data, whether it's warehouses or lakes, or even that Cosmos DB data through Synapse Link. I can develop all of my scripts and notebooks for my Spark and SQL engines, and I can build pipelines. You'll see a little bit of each of these through the course of this demo. But let's go ahead and start in this data lake. So here you can see I've got customer leads as a container. When I flip over to my link services, you can see here I've got a data lake, which is dynamic CDM data. And the giveaway that this data has been aggressed from Dynamics in CDM format, if I scroll to the bottom, you can see model.json. This is the file that effectively self-describes all of the data in this data lake. It describes the schema of the data and the semantics of this data. And we've built intelligence into Synapse that it can understand this and ease a lot of the burden on developing and analyzing this data. So let me show you how this works in pipelines. I'll start by flipping over to my pipeline. And here you can see I've got a managed data flow. And this is also a reflection of the graphical experience for building these pipelines in Synapse. If I drill into this, you can see here I've got a code-free data flow. And connecting on the source, I've got a link service to my CDM data. And then if I click on source options, you can see that I'm putting to account, customer leads, and then model.json for that self-describing format. You can tell that self-describing because I've already got 240 columns up here. And if I want to add additional transformations into this pipeline, that's as simple as clicking on the plus here. And you can see it drops down a whole set of other transformations that I could plug into this pipeline. And some of these would look familiar: pivots, surrogate keys, common data structure methods. I could also actually go and add a new source if I wanted to join this data on the fly. And this is completely graphical as well. I simply click source and then select new. And Synapse has over 90 connectors out of the box. And there'll probably be a whole lot of familiar data sources here. And you could plug these directly in to continue to build out this code-free flow. Once we deploy that, Synapse will actually distill this down into Scala that will run on the Spark engine to execute this data transformation at scale. Now, we've also enabled CDM for the data scientists who might be sitting in these notebooks in Synapse. If I flip over here, you can see I've now got a Spark format for CDM, Microsoft.cdm. And then, of course, the giveaway again is model.json, and I'm hitting that account entity. And I ran this previously, and so you can see I've got some data that I've returned. But this now enables Spark engineers to sit directly in a notebook experience and access CDM format natively without needing to pick through these files and folders to figure out what they need. Let's flip over to the data sharing and see how that works. I'm going to go over to the Azure portal now. And here I've got a data share that I set up earlier. I can jump into my data share. And if I flip down here, you're going to see I've got 5. My data share here, and I could start sharing data. Here I've got 3 that I set up earlier: sales data, product data, and inventory data. Now, the really powerful thing about Azure Data Share is it's completely open and flexible for sharing any kind of data. I could share data from my data warehouse tables if I'd like to share them internally in my organization or externally, perhaps with upstream suppliers. But I can also go and share that. I can also share data out of my data lake. You know, it's common that you could have data in your lake that you're accessing with one engine, one compute engine, but an external party might want to bring a different compute engine in the cloud to perform a different type of analytics. And the openness of Azure Data Share to share, you know, delimited and Parquet format, for example, but even things as extreme as sort of images and audio, those things we don't commonly associate with analytics, that's the flexibility of Azure Data Share. It's a really powerful platform. Let me flip back to the demo, and now we're going to sequence into demo number 2. Demo number 2 shows schema inference. And so I'm going to go run this query. And what you'll notice here is I'm just selecting the top 200 star. And so there's no column definition here. There's no type definition or anything like that. But at the same time, I'm querying a CSV. Now at Ignite, we showed this functionality for Parquet. And Parquet has a header, it's self-describing, and we can capture that schema. But in CSV, we don't have that. And so the new parser in Synapse enables me to walk directly up to delimited files such as CSV and just run a select star query, and we'll infer that schema. It's a great productivity booster to, again, save you a lot of manual schema definition for files. But let's keep moving on to demo number 3 now. Here I am, and I'm back in my data lake. And this time I'm looking at a whole set of Parquet data. I can right-click a Parquet file, and I want to bulk load this into my data warehouse. So I can click New SQL Script and bulk load. Here you can see we've got a new wizard appearing in Synapse Studio. I've got a storage account and input file and folder. I'm going to click Continue and then Continue again. And while it's inferring the schema from the Parquet format, we can take a look at what we've got here. So it's automatically detected the format of that file. It's automatically detected the compression, and the max errors was set to 0, and that's good because I don't have any tolerance for errors or missing data record in this data. I want to load this into my DWMV database. I'm going to give it a new table name called dbo. Let's say table loader perhaps, O-A-D-E-R. And I can look at the column mappings here. And here you can see that schema inference that I was talking about. It's automatically detected all of my types, my column names, and my destinations. So I'm going to cancel out of that one again. And what I'm going to do now is open this script. Here it's generated a new SQL script. And to save me a lot of time, it's automatically created all of the schema for my table. But it's also created a copy statement. And copy statement is what we now use to load data into tables directly off the lake. But what you'll also notice is it's given me a little wrapper. It's commented out the stored procedure that surrounds this. I'm going to go ahead and create this stored procedure quickly by running this. And if I flip back over to my data now, which I can do here, and I'll open my workspace, MV, programmability, and store procedures, I've now got this new store procedure. So let's say I want to automate and operationalize this store procedure for continual loading into my warehouse. That's incredibly easy with Synapse as well. I just click on the ellipsis here, add to pipeline, and select new pipeline. Here it's going to go and create a pipeline for me. And you can see here it's got a store procedure activity in the pipeline. I can add a trigger, new, select the trigger and new. And what's here is I can select event-based processing amongst scheduling or tumbling windows as well. With event-based scheduling, every time a file lands in the storage, this store procedure or pipeline is going to automatically invoke to load that data into the warehouse. So it's great for continuous loading scenarios where data is constantly landing in the data lake. It's also really useful for scenarios where your data is arriving at relatively variable times perhaps, and putting a fixed schedule may run too early sometimes, so you can just trigger it on arrival. But at least when that data is landing, you're getting it directly into the warehouse and you don't have to wait or manually check that it's there. So I won't run that now. Let's flip back out of this and go back to some of our other demos. I'll discard that change, and this one as well. So now let's flip over and look at streaming ingestion. So I've got a query here, which is going to show you streaming data coming into the platform. But before I show you that, I'd like to show you how I'm actually running this hot path analytics in Azure. So I'm going to flip over to the Azure portal again here. And here you can see I've got a job that I set up previously, which is streaming data directly into tables. So what I just showed you before was a scenario for event-based loading where the data hits the data lake, and then you could operationalize that in a pipeline. Here we take that one step further and we enable you to point a hot path stream of events that are coming directly off IoT devices, for example, and coming through an event broker. In this example, we're using Event Hub, and streaming directly in a table for analytics. So if you take a look at this, I've been looking at this for the last 30 minutes. And in the last 30 minutes, this stream has processed 184 gigabytes of data, which is pretty significant throughput, or 360 odd gigabytes an hour per hour, and then you can extrapolate that per day. Let me just show you what's actually happening in this hot path as well. If I flip back to the overview here, you'll see a couple of things. First of all, I've got two outputs. And if I click on one of them, I'll take granular. You can see that I've got a database, which is right here, stream DW, and a table. So this reflects that I'm streaming directly into a table in my data warehouse in Synapse. I can close this, and then let me show you a couple of other things. Here are the two select statements that are actually outputting to each of those outputs. So into granular, you'll see there's no aggregation at all. This is just basically a pass-through firehose stream. And so these millions of events that are landing, I'm sending them straight through. So I've got the most fine-grained data for analysis in my warehouse. But with stream analytics, I can also go and do temporal analytics directly over the hot stream. Here you can see that I'm averaging the temperature and taking a max as well. Over that same input, I'm outputting that to DW aggregate, and I'm doing this tumbling window. This is a temporal semantic where I'm effectively aggregating on a per second basis. At the end of each second, I insert that into the database. And so this is a great example of bringing hot path analytics, looking at data in an exact time window as it's flowing, even before it's been stored anywhere in Azure. And I can commit that to warehouse as well. And of course, this output could also be written to other places as well. So let's go back to Synapse Studio and see what this looks like. I'm going to go take a quick look at DW aggregate first. And you'll see here we've probably got maybe 50,000 rows or so since I last ran this, more, about 500,000 rows. But let's take a look at granular. So if I go run this, we're going to see I expect millions of rows, significantly more. And if I flip down here, let's just put some commas in it to prove this number. We're at about 366 million rows that have streamed into Synapse. Let's go take another look at that to see if we've changed already. I'll run this count again. We're already up to 367, almost 368 million rows. So just in that short window that I put the commas in that number, we've already added another million events into the table. And this is going to just run continuously to capture that really fine-grained data. And so we've shown two things here. We've shown bulk loading through pipelines and how quickly you could operationalize that. We've also just native streaming coming to the table. It's a great toolkit for your scenario and however you want to ingest that data. Of course, once it's all in Synapse, you can write single queries to join all of it, including that Cosmos DB data that we described through Synapse Link. Let's keep moving now to look at some of the enhancements we've made in the SQL as well. And for materialized views, I'm actually going to flip over to show what this looks like in Management Studio because it's a little easier to do a side-by-side comparison. So in this scenario, I've got two queries. They're exactly the same. The only difference here is that if you take a look down the bottom, I've got WWIDW, which is an older version of the Synapse SQL engine prior to build. And on the right-hand side, you can see I've got DWMV, which is the current version that we're shipping at build. In both of these scenarios, I've created a materialized view. Now, materialized view basically takes that select statement and persists that result set as a view. And so it gives the optimizer an opportunity to leverage it if it can execute a query more efficiently. And so I've done something quite intentional here. I've actually created a select statement across tables A and B. They're probably not real world names, but they're suitably simple just for the sake of this demonstration. And so I created this view in both sides on both clusters. If I go and run this, and I ran it before, what you're going to see is that the query here, despite querying tables A and B with a suitable join and a suitable aggregate, which I did in that materialized view, still has to reference each of the three tables. So if I show you this, there's table C, and then here's table A, and then the other one is table B as well. So my materialized view has not helped me in this scenario. But if I come over to the model, the current version that we're shipping at build, you'll see we've introduced partial matching. And this is really powerful because what it means now is that developers can be writing queries, can be building reports, and they don't need to reference the materialized view as explicitly as they did previously, leveraging those capabilities, and the optimizer can still apply it to the query. And so here what you can see if I mouse over is I still need table C. I'll just zoom in on that quickly to show that. I still need table C. Because that wasn't in my materialized view. So of course we need that table to resolve the query. But if I show you this one, and we'll zoom in on that quickly, you could see it's hitting DBOVAB. That was the name of my materialized view, A1 and B1 from that materialized view. So what does this mean for developers? For developers, it means that you can now take complex workloads and write a materialized view that might represent a large number of queries where they have sort of diverse characteristics each. But it also means that for an analyst, I could go run this query on Synapse, and that's going to come back very, very quickly. But in a more complex join, this is going to take longer. And so this is the benefit now of introducing this materialized view optimization. Let's flip back to Synapse Studio and keep moving. We also introduced scoring predictions. So in this, the predict keyword. In this scenario, you can see I've got predict, model, and trips. And I'm going to get to this query in a second. I'll start by querying the models table. So in the models table, you can see I've got a string here, which doesn't really mean anything, but this is actually predictive model stored in the Onyx runtime format. And then I have a table called trips, and the trips table has about 7 columns of data. And this is important: vendor ID, passenger count through day of hour. Let me come down and run this query. And as I mentioned, we've got this predict keyword. When I go run this, you'll see that I'm querying from predict. I'm plugging in that model value that I populated from the model table, and I'm referencing table trips. This means that I'm plugging in the 7 columns from trips as variables into executing that predictive model. And we've now got this total amount column, both defined here and then referenced in the select statement. This total amount column down here, I'll just grab that one quickly, does not physically exist in the database. This is a prediction. It's a prediction that was calculated in the query execution, but because it's in SQL now, I can start to use that column as I would any other column. And so if I scroll down a little further, I can show you a slightly more complex query where I'm actually doing some more common SQL things. So here we've got a similar query nested, but once I take that total amount, I can go and apply a SQL average to it here. And then in my outer query, I'm going to go and apply a rank function to stack rank and order that within my query. So let's go run this. I'll lift that up, and we're aggregating against the passenger count. So in this scenario, we're going to get 6 records back right here. And this rank, of course, is because my average trip amount for 3 passengers is higher than any other average trip amount. So applying some of those really familiar SQL skills that we know over predictions directly in the SQL engine. And then, of course, because, like I said, this is SQL, we could put this in a view, we could put this into access this through Power BI or other tools as well. But let's keep moving. We've also enabled support for the merge statement, a long-standing ask for a lot of customers. Merge is now supported in the distributed SQL engine in Synapse pools. I could go run this, and this is just going to run as well. Really powerful for those slowly changing dimension scenarios. We've also introduced ANSI-compliant joins into update delete statements. Here's just an example of an update with a couple of inner joins in it. I can run that. I can also go run a delete statement, which is similar. And as a bonus, and I didn't mention this earlier on, we can also go and now run multi-column hashing for a table. And I can show you that right here. This is a key enabler for migration. There's a lot of legacy platforms, distributed systems that have supported multi-column hash distribution. And in Synapse pools, we've only ever supported single column hash distribution, which meant you had a design decision to make when you're bringing that data into the platform. Multi-column hashing, or even hashing in general, is a very powerful optimization feature. Not only does it enable you to distribute your data in a specific way certain to your workload, it enables the query optimizer to do some very intelligent things to co-locate optimizations or parts of the query on nodes and minimize that data movement. And so multi-column hashing now is an enabler for bringing these migrations into Synapse, and it's one less decision you might need to make about re-architecting your data. But let's keep moving again. I mentioned that I also want to sort of peek into the future and show you what we're doing around hardware acceleration in Spark. And this is the 4th and final demo. So over here, I'll flip into Spark, and you can see I've got a basic notebook here. I'm not going to run this. I just want to walk you through a couple of basic things. Here we do a couple of imports at the top. Anyone who's developed in PySpark, this will be pretty familiar to you. I go and reference a few locations in my data lake. I'm setting up a schema here over the data. And then down here, I'm defining my data frame. And you can see specifically I'm pointing to a CSV file that I referenced above. The key feature that we've enabled here is hardware acceleration for this CSV parsing. And so I'd like to show you a demo that we pre-built because it's hard for me to sort of explain the true impact of this performance in the notebook. We just don't have the capabilities to show you the performance characteristics. I'm going to flip over to this UI we built. And this is a replay of a run that we ran earlier before the session. Basically, what we did is we ran this job on a CPU-based cluster using the default nodes that are in Synapse, the Synapse Spark pools today, and then also against FPGA, which we'll be introducing in future. So it's not there today, but we're going to be bringing that one in the future. But it's really useful for showing the performance characteristics. So when we ran this against the CPU, it was able to process about 76, maybe got up to about 80 megabytes per second. And so you can see here, we're still up to about 700 megs. But what do you think happens when we light this up with FPGA hardware acceleration? The exact same script running this job. We can see with FPGA, we jump immediately to about 1300 megabytes per second. We're already getting close to 10 gigabytes processed. And with Synapse, we're still only on about 2,500. We've already blown straight through it. So FPGA acceleration is something we're working on right now. It's something we're planning to release relatively near term in the future, but it's just a peek into some of the ongoing performance optimizations we're putting into Synapse to help developers be more productive and get through some of these big data workloads faster. So let's flip back to the slides and tie a ribbon around everything that we've talked about here. So the 4 demos we looked at started with looking at the common data model support in data flows and the ability to natively understand that model.json file, taking data that's egressed out of something like Dynamics 365 CRM and basically making it instantly accessible both through data flows and to Spark engineers for analysis. And then we had a quick look at Azure data sharing as well and how we could share that both internally or externally with other companies securely. We took a quick look at schema inference, the ability to just walk up to a CSV file and say select star and get a tabular result set from that. And of course, you could then iterate the complexity of that query. We took a look at the new bulk loading wizard and the ability with a few clicks to operationalize that for event-based loading, continuous loading scenarios directly out of cloud storage into your data warehouse. And then we took that one step further by looking at actually true streaming, doing hot path analytics over the data, doing temporal analytics on that stream, or regressing high throughput directly to tables as well. We had a look at some of the SQL enhancements, the materialized view matching, partial matching, so that analysts get higher performance and developers can generalize some of those result sets performance into a materialized view. And the query optimizer in Synapse will automatically match that materialized view. There's no need for developers to explicitly query that materialized view by name, because really that's hard for them to do, to understand what they would need to do there. We showed merge, updates and deletes, and joins in updates and deletes as well. And we showed the multi-column hashing as well in the table definition. And then finally, we showed the hardware accelerated file parsing for FPGA. Like I said, not there yet, but something that we're working on soon. So let's wrap this up. As everyone knows, Synapse is a single service. It's in public preview today as of build, and it brings together all of these capabilities: SQL, Apache Spark for Synapse for data science workloads, pipelines and code-free data flows for that data integration, over 90 connectors for connecting data both on-premise, hybrid connectivity, connecting to other clouds, or even native SaaS applications. And then the Studio, that single integrated experience, but then we also had a quick look at Management Studio to illustrate the backwards compatibility of existing Microsoft SQL tools connecting into Synapse. All Up Synapse provides a full end-to-end experience. The one thing we didn't have time to show today, of course, is the Power BI authoring experience that's also in Synapse Studio. We've got some other demos for that, and you can take a look online to see what that looks like. So how to get started today? There's a couple of links here. Of course, we've got free trial accounts, AKAMS Synapse_analytics. There's a link here as well. We had a lot of interest for data share. I didn't get a lot of time to show it in depth today, but AKAMS Synapse_data share is a great place to get started and learn more about that capability. And then we've got a getting started toolkit as well to help folks get started on Synapse. So with that, I'll thank everyone for joining the session. Hopefully it was a really useful session just to see a glimpse of some of the Synapse features that we've launched to build and plan to launch in the future. The preview's available today. I encourage you to get started on the portal, go provision a workspace and get started. And with that, we can probably wrap up and see if we've got any Q&A. Matt?
All right, thank you so much, Charles, and thank you so much for showing the power of the latest Azure Synapse features. We have about a minute left, so what we'll do is we'll do some quick fire questions. So first of all, when do you expect the service to become generally available for everyone to use?
Yeah, always the first question. So our target for GA right now is pretty broad. We just got into the public preview. We're targeting to get this out in the second half of 2020. Like anything, GA is going to be predicated on the feedback we get from customers. So I certainly encourage customers to go and provision the preview and take a look at it. We want to make sure that we ship a rock solid GA product, and we know there's some more feedback that we want to take from customers before we do that.
Great, thank you so much. And I think that's all the time we have. So Charles, back to you.
Fantastic. Well, thank you everyone again for joining the session. I appreciate your time today. Like I said, get started with Synapse. There are some links here. Documentation is online and it's available in the Azure portal today. So thanks a lot and enjoy the rest of Build.